Now let's move to section 2, NLP foundations for testers. NLP understanding is essential for anyone testing AI-based applications like chatbots, assistants, summarization tools, or for that matter, LLM-based applications. This section explains core concepts like tokens, embedding, attention, and generation in practical language. The goal is to help testers understand what's happening under the hood when an LLM processes text and produces response. Natural. So what is NLP? It's natural language processing is the pipeline that turns human language into a form models can work with. The flow shown here is language to tokens to embedding to models to output. Tokens are the smaller pieces of text the model actually processes. Embeddings convert those pieces into numeric vectors, and the model uses those representations to produce a final response. For testers, understanding this pipeline helps explain why wording matters and why seemingly small prompt changes can affect outputs significantly. Tokenization. So, tokenization is the process of breaking text into smaller units the model can understand. In this example, the phrase AI testing becomes separate tokens that the model can process as word pieces. This matters for QA because token limits affect the prompt length, memory, truncation, and sometimes even cost. Testers should be aware that long prompts may be cut off or proceeded differently once token limits are reached. Embeddings vector space. Embeddings convert words or sentences into numeric vectors that capture meaning and context. In the visual, semantically similar items cluster closer together, which helps explain how models identify related concepts. For testers, this matters in use cases like semantic search, similarity matching, recommendations, and intent detection. It also introduces a new kind of risk, embedding drift, where shifts in data or model behavior change semantic relations over time. Attention mechanisms. Attention is one of the core ideas behind transformers. It allows the model to weigh which words are most important when predicting the next token. And those weights can be visualized as heat map. This is useful because it helps explain how context is preserved or lost across a prompt. From a testing perspective, as we want to verify the model continues to focusing on relevant tokens during topic shifts and the performance degrades gracefully as inputs become longer and more complex. Generative models, output prediction. Generative models work by predicting the next token based on context, then repeating that process to build a full response. Because the prediction is probabilistic, outputs can vary depending on sampling settings such as temperature and top-up. Even small prompt changes can alter downstream results. For testers, this means we should validate not only correctness, but also style, reasoning quality, and factual reliability. And we should use deterministic settings when repeatability is required for testing. Hands-on exercise. This exercise helps make tokenization and embedding more concrete. The task is to take a sentence like login API should return 401 for invalid password. Break it into tokens and show embedding as simple illustrative vectors. The learning goal is to connect theory with a QA example that feels familiar. It shows that even a common API test statement is transformed into a representation the model can analyze numerically rather than linguistically in the human sense.